Hey all, welcome to ShareTreck. This is Raj here. Friends, today I'm going to talk to you about a company which is not yet in the stock market. It's a startup, but it's a very powerful company in my opinion. It's Arbor Biotech. I'm going to talk about that today. We need to keep track of this company. It could make a big impact on the genomic medicine field. It's a platform company. Let's get started. Welcome back, friends. In our channel, we not only look at the genomic companies that are listed in the stock exchange, but also we try to identify new startup companies which are in significant technology areas or disease areas which could make a splash so that we can catch them as soon as they come in with the initial public offering or they come through a SPAC into the market. We want to catch them early. So if you recollected, we had identified Excision Bio and American Gene Technologies. Both of them are working on leading edge solutions to cure HIV. Now there is this other company which is Arbor Biotech. I think it's going to be a great platform company because it's going to usher in next generation gene editing. I would consider CRISPR-Cas9 as the first generation. It had limitations. It had defects which prevented it from being used for a big range of gene editing tasks. But then we had base editing and prime editing, and now Arbor has come up with a very different approach and a philosophy. Feng Zhang is the one of the co-founder of Arbor, and if you remember, Feng Zhang is also instrumental in the discovery of CRISPR-Cas9 and the patent battle between Broad Institute and CVC still continues. And Feng Zhang, I think, missed an opportunity to get a Nobel Prize for discovering CRISPR-Cas9. But that's a story for the past. Feng Zhang has then gone ahead and he co-founded Beam Therapeutics as well, and Sherlock, and a few other companies. And in Arbor Biotech, they are looking at AI and machine language in order to fine-tune nucleotides and proteins in order to meet necessary target requirements. Here we are in the website for Arbor Bio, and let's go to what they do. They have the next gen gene editing, and they are talking about improving upon Cas9, which typically is a bulky molecule. And with CRISPR-Cas9 combination, we do have the issue of fitting it into AAV, which has got a smaller payload as compared to lentiviral vector. And also we know that there is off-target editing issue with CRISPR-Cas9, and we need a more precise cutting so that the repairs can be proper. So they are going ahead, and they have a suite of nucleases with PAM diversity to target more than 93% of human genome. So one of the things that you need to remember about CRISPR-Cas9 is that the CRISPR-Cas9 combo needs the edit to be done adjacent to a PAM. So if the edit needed to be done is not adjacent to a PAM, then you cannot use CRISPR-Cas9 for it. So when Arbor Bio talks about a suite of nucleases with the PAM diversity to target more than 93% of human genome, that's a tremendous improvement in my opinion. And they have a toolbox which enables a variety of functions spanning from simple knockdowns of a protein to more sophisticated and precise ways of editing the genome. And they have chosen to focus their efforts on 4 primary platforms for editing DNA, each of which contain unique properties that enable a differentiated approach that can be used for many diseases. And that discovery approach consists of identifying protein from nature. So they have discovered and identified 3 billion plus proteins up to date, and they use AI and machine language to optimize. And using AI and machine language, they have been able to generate 9 proprietary gene editors and 6 times more nucleus families than are published in literature. So if you were able to get into their website and look at this particular page and zoom into, let me zoom this a little bit more so you can see a bigger picture out here. So all the blue dots that you see here, these are all the Arbor discovered nucleus families, and the ones in orange are the ones that are already published in literature. So there is a whole lot of nucleases that gene editing companies can license from Arbor in order to target specific genes, to target specific diseases and conditions. And now we are not only talking about diseases, but with these kind of nucleases, it's possible to target genome of any organism. Now, if you look at engineering, Arbor claimed that they have been able to engineer editing efficiency which is 30 times more than the wild type nucleus provides by engineering the wild type nucleus and finessing it. And I suspect they must be using AI and machine language in this process. And the resultant modified nucleus is 30 times more effective than the wild type. So this is a whole lot of achievements out here, and it's just a matter of time before gene editing companies discover these tools that are offered by Arbor Bio. Well, friends, the simplest way in which I could explain how I conceptualize Arbor is by taking the example of this driver that I have. Now, I've had this for a long time. I do a lot of small work here and there in the house. So I have a drill bit here. This helps me to drill a hole. So I can use the same machine, but I'm going to change it into a Phillips driver. Now I can drive a Phillips screw. So this works. And if instead of a Phillips, if I got a minus, I have a minus. So I have a whole lot of these, a box full of these kind of attachments that I can replace on this drill, and basically it does the job. So when I have the right bit, I can do the right job easily. When I have the wrong bit, for a plus, I cannot use this one. So now when you look at gene therapy and the companies that make gene therapies, the problem in front of them is that using genomic sequencing, they could find out what pattern of the gene causes what kind of diseases, and they know what is the baseline, so they know what changes they have to make in the genes. Now, where the gene is located, is it adjacent to a PAM or is it away from a PAM? Is it just one spelling correction that has to be done, or a whole section has to be changed? These are all the various questions that they need to answer. And once they have an answer for that, I'm pretty sure they're not going to go for CRISPR-Cas9, but instead of Cas9, which I would say is like one of these, they are going to go for something specific from Arbor, which would be like these. And they will be specific for the use, because Arbor has got a whole bunch of nucleases which are not yet published, and they are very specific in their approach and in what they deliver. And besides that, all these nucleases are much smaller and they can fit easily into the AAVs. So I'm thinking that Arbor is going to be a game changer for the industry, and I'm expecting that very soon we are going to see a lot more deals for Arbor. And that basically means that sooner rather than later, they might come up with a share issue, or they may merge with a SPAC and go public. Whatever happens, we got to keep track of this company, in my opinion, so that we don't miss the opportunity. So that's all for today, my friends. Please let me know what you think of this. Put your thoughts into the comment section. And yeah, I'll see you in the next video. Till then, bye for now.